Logarithmic functions. The logarithmic function y equals log base a of x, where a is greater than 0 and a is not equal to 1, is the inverse function of the exponential function y equals a to the power of x. It is read, y is the logarithm to the base a of x. It is defined by y equals the log base a of x if and only if x equals a to the y power. The domain is the set of positive reals. The range is the set of reals. Y equals the log base a of x if and only if x equals a to the y. The output of a logarithmic function is equal to an exponent on the same base. This is because the range of the logarithmic function is equal to the domain of the exponential function. The input of a logarithmic function is equal to the output of an exponential function of the same base. This is because the domain of the logarithmic function is equal to the range of the exponential function. Some examples. If 2 equals log base 2 of 4, then 4 equals 2 to the second power, and vice versa. 3 equals log base 2 of 8 if and only if 8 equals 2 to the third power. 2 equals the log base 5 of 25 because 25 equals 5 to the second power. 4 equals the log base 3 of 81 if and only if 81 equals 3 to the fourth power. 1 equals the common log of 10 because 10 equals 10 to the first power. 2 equals the common log of 100 if and only if 100 equals 10 to the second power. And 3 equals the common log of 1000 because 1000 equals 10 to the third power. Example, solve the equation 3 equals log base 3 of x for x. Step 1, rewrite in exponential form, that is, invert. 3 equals the log base 3 of x if and only if x equals 3 to the third power. Step 2, simplify the exponential form. 3 to the third power equals 27. The solution is x equals 27. Example, solve 5 equals the log base 2 of x for x. Inverting, x equals 2 to the fifth. Simplifying, x equals 32. Example, solve -1 equals log base 8 of x for x. Rewrite in exponential form. We get x equals 8 to the negative first power. Simplifying, according to the laws of exponents, x equals 1 over 8 to the positive first power. That is, x equals 1/8. Example, solve 1/3 equals log base 16 of x for x. Inverting the equation, we get x equals 16 to the 1/3 power, which means x equals the cube root of 16. Simplifying the radical, we get x equals the cube root of 8 times the cube root of 2, or 2 times the cube root of 2. Example, solve 0.5 equals the log base 9 of x for x. Inverting, we get x equals 9 to the 0.5 power, that is the square root of 9, or x equals 3. Note that only the principal root is a solution. Recall the domain of the logarithmic function. Example, solve 1 equals the natural log of x for x. The base of the natural log is e, so x equals e to the first power, or e. Example, solve 5 equals the natural log of x for x. Inverting the equation, we get x equals e to the 5th power, the solution.